Hi guys, welcome to the session on Python, and as part of today's session we'll be looking at the primitive data types in Python. So we'll be looking at the functionalities in each and every data type and other features along with all these data types. And before getting started, I will be just briefing you about that version of Python what we are going to use and the IDEs for this particular session and the future sessions as well. So the version is concerned, we are using Python 2.7. Why 2.7? It is the most stable version in the industry, and if you are starting from scratch, it's always better to go with 3.x, any version in 3. But since 2.7 is the most widely used version, I have chosen that, and that is a version you will be seeing for this tutorial as well as for the future tutorials. And as far as the ID is concerned, we are using PyCharm. So this is the PyCharm screen. So you will be seeing this where you see the tree structure here, the code window here, and there will be one more window which will be opened up when we are running any Python code. That is your output window. So this is the ID we will be using, and it is a community edition. You can download it for free, and there is an enterprise edition also which we are not using it here. We are using a community edition. So the prerequisite here is you have to install Python 2.7 and you should have an IDE, so which will help you to learn the future sessions as well. So that's it. Right, so let's get started. And before getting started, there is one more thing which I want to say you. Python is entirely a dynamic language. It doesn't bind you much with the data types. So what do I mean by binding much? So let me say you with the other examples. Let me open a notepad. Right. So suppose I want to declare an integer in some languages like Java or C, C++, whatever language you are familiar with. So normally this will be the notation. You will put your data type int, then your variable name a equal to 100 something. So int represents your data type, whereas a represents your variable name and 100 is your value. This is the syntax you will be following in most of the languages. Suppose in due course in the same program, if I try to assign a equal to apple, then you will get an error because in your code you have defined a as an integer, but now you are trying to change that value of a to a string, which is not allowed in your programming language. This is the same thing followed in most of the programming languages, but Python, it's a bit different. Here everything is dynamic. Here there is no declaration of any of the data types. So that is one thing which makes Python more powerful. At the same time, here the data type is determined at runtime. So that is one of the advantage of Python. So let's look at it. So theoretically speaking, Python is totally dynamic, but let's see how it works in coding aspect. So I'm just going to the Python interpreter. This is your Python interpreter. If someone has any questions on how to get to this interpreter, it's very simple. So just go for command prompt. This is your command prompt. From here, you just type Python. That's it. You'll get into this screen. So it's as simple as that. To get out of the screen, just type exit. You're out. Exit again. You're out of your command prompt. So I'm using this a Python interpreter, and if I want to type something in the IDE, I will be using this script. So I'll be toggling between these two screens in most of my videos. So kindly bear with me. Right. So this is our interpreter. Now I'm not going to use something like int a equal to 10. I'm just going to do a equal to 10. To check what is the type of a, you have to use type of a. That's it. It says that it is an integer. See, I have nowhere declared that a is an int, but Python automatically identifies a as an integer based on the value whatever has been assigned to that particular variable. This is what exactly we say it as dynamic assignment. So in Python, dynamically all the variables are taken into their data types and not something declared upfront before getting assigned. So in all the languages you have to put something like int a equal to 10, but here in Python we don't do that. So let's do with some operations. A plus 5, you can do addition, a minus 5, a star 5, a divided by 5, get all those things, and a star 5, See, star star 5 is the exponentiation, or you can say it as a power. A to the power 5 is written as a star star 5. And when you deal with things like a divided by 3, you get your quotient. So you get only the quotient. Remember, you don't get your decimal points here. Suppose you want your decimal, or you want the remainder, you have to put a modulo 3 where you get your remainder. Remember, slash gives you only your quotient, not your decimal point values. So this is as far as your integer is concerned. But there are other type of integers which we say it as a long integer. So what do you mean by long integer? When I want to save something like a value like this, now check the type of a. See, it has been written as long. I didn't say anywhere that it is a long integer, but automatically Python takes the value as long integer. Now when I want to print the value of a, you see it is denoted by capital L, which means it is a long integer. Suppose I want to assign a value which has to be saved as a long integer, then I can give something like this. Either small l or capital L, both will do this purpose. See here, 10 has been stored as long. It's not taken as integer. I can give it using a small l or capital L. Both will do the job for me. Got it? So this is something very simple. But here, if you are saving something like a value like 10, which can be stored in an integer itself, which means you are wasting a lot of memory here, as you are saying that 10 is a long integer when compared to integer which will be taking less space for you. So that is one thing which you need to have it in mind. But anyway, what can be the maximum value I can save it in a so that it remains as an integer? That can be one question popping up in your mind. So that is very simple. 2 power 31, you get a value. So 2 power 31 is long. If I give something like this value, when I take this, suppose I'm assigning it to a. Now take the value of type of a, it is an integer. So the maximum int value is 2 power 31 minus 1. This value minus 1 is the maximum int value that can be accommodated in your variable. Suppose if I give a equal to 648, type of a is long. You got the difference? And the same applies for your negative values as well, because there are negative integers as well in our programming. So 2 power 31 minus 1 of your negative integer, also the same range. So this is the entire range where you get your integers. Anything beyond this will be stepping into long integers, right? So when I have a as 10l, if I want to add 100 to it, the result will also be long integers, because Python always compares the two data types. A is a long integer, 100 is an integer. So the end result will be always the higher data type. So in this case, it's long integer. That's it. So these are the two different types in Python for integers. One is integer and another thing is long integer, where a long integer takes more bits to store the values, and it will be wasting a lot of memory if you are saving some smaller values in that data type. Now, the next thing is float values. See, once again, I didn't give any data type and it is saving everything in the form of float. Alright, you can do all your stuff like addition, subtraction, multiplication, division. See here, while doing a division, it is giving you the decimal point values, which is something which we didn't see in integers. When I did something like this, I got my quotient. But when at the same time, when you do like this, you get your result in the form of decimals. That is one thing, because this is an integer, this is a float. Your result will always be the higher data type. So the higher data type is float when compared to integer and float. So that's why you are got in the form of decimals. It is not necessary that only your denominator should be in decimals. Even if your numerator is in decimals, you will get the same result. So just have it in mind. If you want your output to be in decimal format, make sure that one of your numerator or denominator is in float format. That's it. right? So you can do something like, again you can do your power and stuff. So we are done with integer, long integer and float, and the operations whatever you can do, all the arithmetic operations can also be done with your float, long integer and integer as well. Now we'll get into the next type called octal. See, I'm assigning a as 0 1 2 3. When I type the check the type of a, see it is showing as integer. Let me print the values. So a is printed as 83. Whatever I have saved was 0 1 2 3, because the value, when you prefix something with 0, it means Python takes this value as octal and converts that into an integer and then saves it in a. That's what happens here. How to confirm it? Let's try the octal of 83. Octal of 83, you will get back 0 1 2 3. Or you can check even octal of a, which is 0 1 2 3. So you can save your octal numbers in Python, which can be easily identified using octal function. Octal is an inbuilt function which we can try it. Similarly, next to octal is your hexadecimal. I can save the hexadecimal values as well. See, check it once again, it's integer. Let's try to print the value of a. See, it's 4660. This is not which I saved it as 0x1234. Now when you want to check the hex of a, you will get back 0x1234. And the notation, it's not necessary that you have to use small x. Even if you put something like capital X instead of small x, then that will give you the same result. So we have seen two special things, hexadecimal and octal, and there is one more thing called complex numbers that can also be done using Python. So a equal to 3 plus 5j, type of a. See here, so dynamically it is taking the complex values as well, and all the arithmetic operations will be giving you a complex result. A plus 5j, a divided by 5. So you got it. So you can do all your arithmetic operations on your complex data type as well. This is one thing which you need to have it in mind. Whenever you're dealing with some complex numbers, don't worry that whether Python will handle it or not. Python will definitely handle all those things. Right. And the next type is something very much familiar to us, which is binary. See here, the value whatever I have saved is coming as integer. Let's try to print a. It's 3510. See here, what makes this as binary? This notation 0b. Anything starting with 0b and all your values are ones and zeros, then it is converted into an integer from binary, which means just a 0 prefixed will consider it as octal, 0b prefixed will be considering it as binary. How to get back your binary values? It's very simple. Bin of a or binary of a, you'll get back your old result. It's as simple as that. And you can do all your arithmetic operations. Arithmetic in the sense, here there is no arithmetic, like you can't add some values. Here what you can do is like you can do bitwise operations like AND or XOR, all those things possible. Suppose I have a equal to 50, b equal to 20, then a ampersand b is 16. So how to confirm it? Let's just do a manual calculation. Binary of 50 is this, binary of 20 is this. Let me try it. Binary of 50 is 110010, 110010. Binary of 20 is 10100. Okay, so prefix 0 with that. When we are doing an AND operation, 1 0 is 0, 1 1 is 1, 0 0 is 0, 0 1 is 0, 0 1 is 0, 0 1 is 0. So this is our value. So when we convert this into integer, that can be easily done. Let's me try it. integer of 0p 0 1 4 zeros 0 1, yeah, 16. So that is our value. That's what we got here. You can do your AND operation similarly, OR operation, you get 54. Let's try to do the same thing for OR. 1 1 0 1 1 0. This is our OR operation. So 1 1 0 1 1 0 1 1 0 1 1 0. We got 54. That's what we got. Exclusive OR can also be done with a cap symbol. We got 38. So exclusive OR is something like 1 and 0 will be 1, 0 and 1 will be 1, even 1 and 1 will be 0. Exclusive OR is that 1 0 0 1 1 0. So let's convert that. 1 0 0 1 1 0 1 0 0 1 1 0. Got 38. So the bitwise operations can be done in Python. So that is one of the thing which is an advantage. When you are dealing with bitwise operations, you can use these bitwise AND operation, OR operation, and cap symbols, whichever required. Right. And the last primitive data type means I can say that primitive because we have a lot of complex data types like strings, list, tuple, dictionaries, all those things. So in the last thing in primitive data type is Boolean. A equal to true. This will not work. Or A equal to true. This will also will not work because when you are dealing with Boolean, only the first letter should be capital. Now check the type of A. It's Boolean. Right. So remember, first letter capitals. Rest of the things should be in lowercase. Many people will do a mistake. A equal to, they will make it as single quotes, which will make this entire thing as a string, not Boolean. Remember, when you are dealing with Boolean, there shouldn't be any single quotes. You shouldn't make the variable or the value as a string. So the right thing is type of A. Similarly, A equal to false, type of A. Boolean. So this is what these are the primitive data types in Python. I believe you people will be very much comfortable now in dealing with the data types. It is not complex here because it's very simple. Whatever you are assigning to the variable, that will be taken as a data type, which makes it more flexible for a developer. So it's pretty straightforward and simple in Python. Right, now let's shift gears. Let's get into something to the next level in the data type, which is strings. So let me assign a value like this. Python programming. Cool. Type of yes. See here, you got it as a string. Obviously, it is all dynamic. You consider Python programming as a string. That's what we got here. Now, string is not a simple type. It has a lot of inbuilt functions in it, which means I can apply a lot of functions on the string and get a different result. So functions in the sense which does an operation and gives you a result. It can be whatever it is. Certain functions will convert this entire string into lowercase. Certain function will convert this string into uppercase. Certain things will left pad, right pad, and all those things can be done using functions. So let's see what are the functions available on these strings. How to identify that? So in Python, you have certain functions, inbuilt functions, which help you to get your syntaxes. Certain functions will help to identify the functions on those objects, which can be a string or integer, list, tuple, whatever it is. So the one simple inbuilt function, what we are going to do is use is dir. Dir of yes will give you the inbuilt functions that can be applied on this string yes. So basically these are the inbuilt functions. We can try these functions, but to try these functions we need to know what is this capitalize is going to do, what is this center is going to do, what is this count is going to do. To identify that, we have another inbuilt function called help. Help of yes will give you that. Okay, in this case it says it is for Python programming. I can use STR help on your string. It will give you the complete list of all the functionalities. It says that if you press spacebar, you will go to the next page. Go down, see, capitalize. S dot capitalize will give you a string. See, it says that return a copy of the string S with only its first character capitalized. So you will get your string in the form of first letter capitalized. The rest of this string will be in lowercase. Center, it will return your string centered with the width whatever you are specifying. And you have an optional fill char as well, so that the remaining width will be filled with this fill character whatever you are giving, but that is entirely optional. If you are not giving this, the default is considered as a space value. Anyway, don't worry about all these things. We'll be trying these functions, that time you will be getting it more clear. But see, this is an entire document on your strings. It will go on. If you don't want to see the rest of the pages, press Q, it will come out. But suppose let me check the functions again. I want to just know the help of capitalize alone. It's very simple. Instead of giving help of str or yes, just give s dot capitalize. That will give you that functionality alone, the help on that functionality alone. Now this will be very easy for us. S dot capitalize. Before that, let me print yes. This is our string. S dot capitalize. See, we got our thing. Only the first letter capitalized, the rest of the thing in smaller case. That's what capitalized does. You don't want to worry about doing this functionality when it is recorded in your business. You have to use just the capitalize function. Center is dot center. See, it takes the width as 50 and it is centering Python programming. And remember, we saw an optional fill char of parameter. Suppose if I'm giving star, see what happens. See, it is filling everything, the rest of the thing with star. If I don't give the star, default is taken as spaces. That's what we saw it in help. Let me open that help so that, see, return yes centered in a string of length width. Padding is done using this specified fill character. Default is space. That's what we got. So you have lot many functions in Python. Obviously we are not going to try all the functions, so that I'm just going to give you the creamy layer of these functions. The rest of the things I'm just leaving it for your R&D. You try to explore each and every functionality using help and try it on yourself. So the next thing is count. S dot count of p. Sorry, count is 0. Why is it 0? We have this p here, but why it is showing is 0? It's because Python is case sensitive. We are looking for small p, whereas it is capital P here. Let me try with capital P. You will get the count as 2, which is perfectly matching with our string. Then decode and encode. So s dot encode UTF-16. You can encode your string. See, Python programming has been encoded in this manner. Now let me copy this. Use this string to decode using UTF-16. You will get back your string. Okay, what is a UTF-16? Different encoding and decoding standards that you can apply. If you browse on that, you will get to see lot many encoding standards like this. So I have used UTF-16 to encode, and the same code I have used to decode, I got my string back. So again, what are the other functions? So encode, decode, ends with, I can check s dot ends with. Suppose I want to check whether this string is ending with ing, true or false. Yes, programming, it is ending with in, so that's false. Similarly, when you can check with ends with, I can check for starts with, because ends with, and you will see something called starts with as well. whether the string is starting with in. Python, yes, it is starting with. Expand tabs. Suppose I have a string like this: a/t, b/t, c/t. Expand tabs. It will automatically expand all my tabs. By default, it is 8 characters. Or if I saying that don't go for 8 characters, expand all the tabs with 4 spaces. See, all the tabs will be expanded with 4 spaces. So you can find s dot find p. It will give you the position of your p character. In this case, p's position is 0th index, so it's giving you 0. Instead, going for y, so it says first position. You'll get your find format is one thing where you get it in a different format. Index and find almost the same thing, but find will throw up an error. Sorry, s dot find. Sorry, find will not throw up an error. If it is unable to find that particular character, it will give you -1, whereas index will throw up an error. It will throw up an error if the particular character is not found in this particular string. Format index is alphanumeric. S dot is alphanumeric. Check whether it is alphanumeric. It is false because it's all alphabets, right? Then why it is giving it as false? It's because of this space. Space is not an alphanumeric. It is a special character. You can check whether it is an alphabet. Again, it's false. You can check whether it is a digit. False. Let me take a different thing. Suppose I have a string like this. s1 dot is digit. It is true. s1 dot is alpha. It's false. Suppose if I have s1 as apple, then this will be true. You can easily check it. So this can be used in a lot many use cases, like you can check whether the mobile number is valid. For that you can check your length of your string. See, if in case of mobile numbers you can check it's all is digit, so that confirms that it's all a digits. Then you can check with the length of that mobile number, which should be equal to 10. You can do all those use cases in a single line. S dot is lower. You can check whether it is in lower case. Obviously not. Similarly, you can check is upper. Yes, our entire string is in uppercase. S dot is title. It's false. So what do you mean by title? It's very simple. It will take the entire string and converts all the first letter of the words into capital letters. So we have an inbuilt function called title, which it can do that functionality for us. S dot title. See what happens? From our entire string, only the first letters of each and every word has become capitals. Now this format is what verified in is title. If our string is in the form of this, then it will say that true for is title. Let me apply the same thing. I can cascade this. See, output of this, which is this, will be passed as input for the next function. When I do this, it will give me true. In Python, one function's output can be passed as input for the next function. That is very well possible. This is called cascading of the functions. You can swap your case. S dot swap case, small letter to caps, caps to small. So this, let me try something different. So title will convert the first letter to caps. Again, I'm doing a swap case. This will give me first letter small, rest in caps. Right. So you can split. S dot split. It will convert the entire sentence into words based on spaces. So our string has had a space here, so it will be taken as the split element and each and every word will work. Instead of space, if I want to use P as my split, then see, based on P, we got three words. First one is blank, second one is white, thon, and the third one is you lost the B because that has been taken as a delimiter, and you got the rest of the words. And you can try with uppercase is dot upper. We won't be seeing any difference because our entire string is already in uppercase. Z fill, so that is dot Z fill 50. It will take your string and fill the rest of the things with 0. That is one thing. Split lines will look for all the slash n characters, and it will split the entire paragraph into lines based on the slash n characters. That is one thing. Replace, yes dot replace. Suppose you have yes, I want to replace that with x. Oh sorry, I didn't have any yes. Let me take m. All the m's will be replaced with x, so you can replace. So these are the things you can do with your strings. And when you take up your string, let me take a small string apple yes plus 3. When you will try arithmetic operations here, this will not work because you are doing a concatenation of string and an integer, which is not allowed. So how come plus became a concatenation operator? Because this is called operator overloading. Inbuilt, Python will look for the data type, and if it is possible to do a concatenation using the plus operator, it will apply that functionality. So now I can do like s plus, see here, s is a string and I'm appending another string, so I got the final result as a string apple orange. So yes minus 3 will not work. Yes star 3, it will give you something. Got the result? So it just multiplied the string. So where I can use it, I can do something like this. So I'm just using the string, printing it 50 times, multiplying it 50 times. I can do the same thing with hyphen. You'll get some results like this. So these are the some of the additional things which you want to know it in strings. Okay, I'm just wrapping it up here. So we are done with our primitive types, starting from integer, long integer, float, octal, hexadecimal, boolean, complex values, binaries. Then we moved on with the complex types like strings. So I'm stopping till strings, and we are not done with our data types because Python has a lot of other data types like list, tuple, dictionaries, numpy arrays, pandas, data frames, all those things. But it goes like a chain. Once you understood these Python stuff, string values, then we can go with the rest of the things as well. So okay guys, thank you, thanks a lot for watching. So I'm just wrapping up this session, and in the next video we have additional functionalities of strings like slicing and indexing, starting from index values. All those things will are coming up in the next session. Okay, till then, see you, bye.